So first off, a kind of an apologia to the web and beyond. If you came here expecting an explanation for beyond, it's probably not going to happen. It's to the web and beyond because titles have to balance. And sorry, this is the shameless plug. I've been working on this book for a year, so I've been away from kind of Python and JavaScript, just to put it in context, or at least the cutting edge. So part of this is my discovery of what's been going on there in the last month or two. Yeah, titles need to balance. I couldn't just call it to the web. That would have just been wrong, wouldn't parse. So I thought about to the web with love. I mean, it's a bit kind of hippie and James Bondified for a PyData talk, but the sentiment's there. But no, I mean, to the web and beyond has a certain resonance. And I guess I feel that I should try and give some explanation for what the beyond might be. And I think there are some kind of candidates. We are entering a new realm of virtual reality. It's pretty impressive. I played with some of these myself, and I think the prospects for data visualization and virtual reality are going to be very interesting. So that's pretty beyond. If you leave Python for a year and you come back and it's suddenly 3.5, and you were expecting 2.8, then that's pretty weird. It's got new keywords like async. I've no idea what that is. And it's got a weight. It's suddenly embracing asynchronicity. And funnily enough, that's mirroring some of the developments in JavaScript at the moment, which is trying to do the same thing. Python doesn't have the whole callback soup horror to contend with, but in JavaScript, it's an important thing. Beyond is what happens if you leave JavaScript for a week, because there's a crazy pace of development in the world of JavaScript right now, which I'll be addressing in a minute. It's got classes. Some of us don't like that because we like prototypes and we like telling people that prototypes were better than classes, but it gives you a little bit of syntactic sugar, which is familiar, and if you're a Pythonista, that's going to help. We have inheritance, my God. We've got this fat arrow symbolism, symbols, which makes things look a little bit neater. And yes, we've got async. So JavaScript and Python have converged on this async await pattern, which uses promises and will reduce some of the horrible callback soupism which plagues JavaScript, and that's a good thing. So you've got modules and classes and promises and async and generators and block scoping with let and lots of other stuff. Basically, JavaScript is changing very, very fast. So if you haven't been keeping abreast, it's getting a lot nicer to work with, which is very important if it's going to be producing the data viz of the future. I was trying to distill what I kind of felt about working with Java. I mean, there's some people in this room who work with JavaScript and Python, and what's the kind of other big ideas? I mean, obviously communication is a huge thing. I find with friends of mine, if we've done some data viz coolness, we will be swapping URLs. I mean, our ability to share is enormously enhanced by the fact that you can just stick it on a URL and open it with a browser and it all works, because the interpreter is stuck inside the browser. Distribution goes hand in hand. That's another thing. Obviously, the web is distribution. So if you can't get your data viz there easily, if it's an awkward threshold to get it there, then you're going to have problems. It's probably not going to happen. As I said, the humble URL is a token of exchange. So people are swapping URLs that are data visualizations, and they you can now, you can roll a cloud server in a few clicks. I'll give an example of that later in the talk. Places like JS Fiddle, JS Bin, there's a new site called Block Builder, which means you can turn GitHub gists directly into D3 visualizations. What is happening is an incredibly rich ecosystem is developing because of this ease of transfer, and skills are being freely traded, the standards are rising all the time, and it's happening within the JavaScript ecosystem, and the tool sets are there and the language is there to allow this to happen, which is why I'm a bit skeptical about attempts to transpile from, certain languages into JavaScript. I think they're going to kind of ultimately fail because it's so fecund at the moment, so rich, and the barriers to entry are dropping all the time. I want to sort of discuss JavaScript's development because there's obviously a lot of prejudice you find in the world of programming, especially in Python circles. I think a lot of people's experiences of JavaScript maybe a few years ago now, and they have developed a sense of it that is no longer the real picture. I remember when I was first doing a bit of web dev that was forced upon me, and I wanted to click a button and I wanted something to happen, and I discovered this thing called JavaScript, and you had to do this pretty horrible query selector all, add event listener thing, and then you could get something to happen when you click the button. You could have an alert or a warning. And then there appeared this amazing thing called jQuery, which just made all these little horrible things easier. And bear in mind, in those days, all the browsers were different. They all had their own embrace and extend standards. So jQuery fixed all that. It meant you could kind of just write for all the browsers, and that was lovely. But I think the consequence of that is that people associated JavaScript with a whole load of kind of ragbag of DOM hacks and little utility libraries, and just a general sense of just hacks strung together, not a kind of a language to develop interesting and profound code bases in. So it was a toy. It's ugly, kludgy syntax, slow interpreter, small code bases, difficult to scale. Not the sort of thing you would use to be developing cutting edge data visualization, for example. And let's, face it head on, because I think you should appreciate the sheer ugliness that faced JavaScripters until fairly recently. No modules. If you come from Python, that's astonishing. You have little script tags, and you better put them in the right order, or you'll get all sorts of interesting problems. And you would hack together your own sort of pseudo modules to try and preserve your namespaces. Obviously, Python is very big on namespaces, and that's a great thing because namespace pollution is horrible. JavaScript makes everything global by default. If you don't use a var to define it, then it becomes part of the global namespace, which is just horrible. These mistakes are becoming far harder to make, but that is one thing. This sort of thing could sap your will to live. This is how you get a default parameter, or it used to in JavaScript. It's too horrible for words, but basically if A isn't defined, then you make A 42. You do that enough times, and yeah, the language starts to pall. I'm just picking a few at random. The safe way to iterate a list is just horrible. I mean, it's hacky. It's you can't just do for list in as you could with Python, because you'll probably have artifacts, or you'll probably have array members you didn't anticipate. So that's the safe way to do it, but also just wrong. But we're now in EcmaScript 2016, the new EcmaScript, which is coming to a browser near you, and it's almost there. And we have modules, and we have default parameters, and I haven't used a for loop for years, I think. Arrays have a for each method and enables you to iterate through them. So a lot of the crud and the irritants are dropping away. It is becoming a much nicer language, I can testify to that. And yes, with imports, with modules, you can get a bit more ambitious without having to worry about everything just falling apart. I always like this one. It's now much, much, much faster than Python, JavaScript, almost orders of magnitude on many things like n-body simulations or spectral norms. There's been an arms race between the big boys, and Google led it with V8, and JavaScript is now incredibly fast. For those of us working dataviz, you are getting to a point where you have kind of CPU-age to burn, which is lovely. So you can have lots and lots of things moving around interactively, and it increases the scope of what you can possibly do. So JavaScript's getting better and better and better. It's great. It's wonderful. Why would you use Python? Well, the good news is JavaScript's data processing stack it sucks completely. It's awful. Part of that is to do with JavaScript's number. It's just JavaScript's got this one catch-all numeric type called number, which is neither hind nor hair and does very funny things when it gets very big. You can even kind of have skipped integers and stuff. It's too ridiculous. So yes, basically to create a kind of a NumPy ecosystem in JavaScript is going to require not just syntactic sugar, it's going to require rethinking the basics of the language. So at the moment, so the power of Python's processing stack, which I think is pretty much second to none, is the reason why when you're playing with your data, when you're cleaning it, when you're refining it, you want to be using Python, which suggests this sort of thing. So I cover this particular kind of tool chain or workflow in my book. Python does all the scraping, data collation, everything else. It does the cleaning, it does the exploring, it does the delivery using a Flask in this case. At which point JavaScript takes over and does the transformation, the WYSIWYGs, the pretties. D3 is the library of choice. It's the biggest, by far, the biggest JavaScript data visualization library, and it's fantastically powerful and expressive. What are your options? I mean, are there alternative options to embracing JavaScript or biting the bullet, as I said down there? The IPython notebooks, Jupyter, etc., are fantastic, and I think they're just amazing contribution to the Python ecosystem. We've got Plotly and Bokeh, which can convert matplotlib, etc., into something you can stick on the web that will have some degree of interactivity. We've got Vega, which is a visualization grammar, which you could potentially use to send that to a browser, where it will usually be converted into a visualization using something like D3. They have their use cases, but I also think they have their limitations and problems. This is an example of the Jupyter kind of notebook thing. I mean, these things are wonderful. You can go to the web, you can launch one of these. You're going to need a Python interpreter at the back end, but increasingly some of these widgets, the ones down here, are becoming JavaScripted. So in your browser, you can actually interact with them to a limited degree. The question is how much that limited degree is. So here's Bokeh, and the Bokeh website. We can, you should be able to. Something's happened to Bokeh. I can't click on it at the moment. But if I could click on the Bokeh website, I'm going to try it again, then you would find, there we go. So if we go to the Bokeh website, this is a Lorenz attractor. This is JavaScripted. I can manipulate it, there you go, in my browser window, and I have some basic little things here, pans and the rest of it. Now, it's nice, but it's generic. These are pretty much what you're going to get. You don't have a lot of control over that. It's nice. It's a nice demo, but it's you're relying on basically JavaScript experts to have created this API, this environment for you, and that's not particularly empowering. You're stepping outside the JavaScript workflow when you do this. When you do this sort of transpiled Python to JS, and the JavaScript workflow is a very kind of powerful one. It's got some amazing tools like Chrome web developer tools. And you're applying those to this sort of transpiled code is very difficult. It's hard to work with, and it's very hard to make changes that propagate. I've certainly found, I've tried it. Indirection is just, debugging is probably the larger part of programming, and when you have this sort of indirection going from one language to another, you massively multiply the problems of debugging. If you want anything changed, you're going to rely on a JavaScript expert anyway, so you're not empowered. You're essentially relying on experts to do what you want, and they obviously won't do it in the timescales you might require. Here's one example that cropped up. I just thought I'd sort of make the point. I had to do this particular chart recently for a client, and if we play it, it's a very simple little line chart. And you select various demographic groups, and this gives a kind of a verification score for them. And this is what they kind of specified, they asked for. And the immediate problem is you've got these clashing labels. Now, clashing labels is a perennial problem for dataviz. So the little things that just take up all your time. And so I hacked oops, go on. So you go away, and because you're working with JavaScript and it's all very, and you have control over all of the different elements, you can just very quickly create a little D3 hack that make sure that the labels are reasonably dispersed, and that would be very hard to do within a Bocky, Plotly, or whatever situation. And there's the hacky function that just came together, but it got the job done. And certainly if you're working with dataviz for work, for clients, these little controls, this empowerment is really important. It's fundamental, in fact. Multiple element figures are also quite hard to do. Sorry, I'm just, so this has got multiple elements, and it requires some understanding of HTML, CSS, in order to get these elements to function together. So, all right, just now something's getting well established when Microsoft start playing around here. This is what's called Sandance. It's a sort of it's a Microsoft project in-house. That's all browser-based, and they've written their own little kind of dataviz tools. Microsoft obviously have a potential problem because they don't want to kill the whole Excel ecosystem. And if stuff starts going to the browser, then maybe people won't want to use their open office software quite as much. But you can see the sort of thing people are doing now. They're getting much more ambitious. This was a proprietary Microsoft solution, but it's pretty cool. It's a pretty impressive example of data viz on the browser. So what do you do if you want to get in? Say avoid all frameworks, inoculate yourself against JS toolitis. There's so many tools that you'll hear about. You don't need to worry about them. Many of them are more trouble than they're worth. Initially, just learn the basic HTML elements, invest some time in learning SVG, scalable vectorial graphics. That will really help. Don't worry about less or Sass or compiled CSS, just go vanilla. Go vanilla for everything. Start really simple and don't use a tool unless it justifies itself. Use a tool if you're hitting your head against the ceiling. Otherwise, don't bother. And certainly don't touch frameworks until you're comfortable with vanilla JavaScript, which is a powerful language. So there you go, just an editor. You need an editor that can handle multiple languages. I'd certainly have syntax highlighting. A browser, Chrome debugging tools are really very impressive, and a console for output. We have the concept of the single page app, which is you have a kind of an entry point, an index.html. This is a Flask-based one. That's a self-contained dataviz or web dataviz folder, and it's got the necessary CSS, JS. The data is the interesting thing here. First, you design your visualization. So you just sketch that out on a piece of paper. You write your little index.html backbone, so that's sort of like just tags, placeholders for the visual elements that you're going to create using D3 or JavaScript. A little bit of CSS to get... Do not use the links between these buildings until further notice. It's all very Robocop. To get the positions of those visual elements, and then you will have an entry point for your visualization where the data is fed in. It looks something like this. You sort of queue your data. And then you'll build your amazing thing, which I won't get into because that's D3 and it's a big learning curve. But I'm going to talk about the data just quickly now. Because it's everything. Essentially, you just think of your web data viz as a data feed, and feeding the data is fundamental. And then you pick up the data on the client side, and you turn it into wonderful stuff. How easy is it to deliver data these days? Well, let's consider this is an array of JSON objects. These are Nobel Prize winners. They have various fields that you're interested in that you're going to use to create your visualizations. And we want to be able to deliver these, and we want to deliver them selectively as well. You have something like this. You have a website. That would be your kind of basic server site that will deliver the dataviz page, the index.html with all the JavaScript and the rest of it. And that's going to be making a call out to a cloud-based, let's say, API, data API, which will then send data back to be used. This is a very flexible system. And how hard is it to do that? A few years ago, this would have been quite a challenge. So now, here's this thing called Python, which I think is a very nice little library. It's a sort of MongoDB-based, Flask-based library. It has a configuration file, a settings.py, where you set your Mongo parameters. Heroku, which many of you will probably have heard of, is going to be used to deploy this, but it can also obviously work locally. So it tries to get the environment variables that Heroku will provide, otherwise it has defaults. You set various other things. You have a little schema that tells you what data in the MongoDB database you're going to release. And that's your settings. That is how you create an Eve or set an Eve server running. As you can see, it's a few lines. For Heroku, you'll have a little prop file which will basically say start up the Eve server. You'll have a requirements.txt file which will give you, which suggests, which mandates Eve 0.61. That will call in all of the necessary Python libraries into that virtual environment. And here is the entire process of creating a cloud-based API, Mongo API. You do a git init on that folder with those 4 files. You add them all. You commit initially. You use Heroku to create an app. I'm calling it Eve Heroku. That all works. You add Mongo Lab as an add-on. Heroku has a Mongo kind of sand pit. You can also use a real Mongo. You can use a scalable Mongo DB, which you pay for, but the sandpit works fine for small experiments. That all goes in, you do git push Heroku master, and it spews out this web address, if Heroku at da-da-da-dum. So as you can see, that's just 4 or 5 command lines. You then have a little script to fill it up with your, in this case, Nobel data. That's just you're just accessing a Mongo database. And then you can do curl on your, just to test out your API. Here I'm looking for all French Nobel Prize winners, and as you can see, it delivers them. At which point you've essentially got your data API. You can access that from your web browser, your client, your web browser, your JavaScript, and use it to create your data visualizations. So the conclusion is that, yes, Python JavaScript is the most powerful data viz stack out there. I think I've appreciated that more in the last year, if nothing else. But they both want to use their full potential. And as much as the kind of halfway house transpiled solutions are interesting and definitely have their use cases, I think they're great for educational purposes and everything else, they're not going to cut it in the modern world of data viz, because the standards are rising all the time and the ambition is rising all the time, and you need to get down to the metal, and that means using the tools available. And as I say, the JavaScript development environment is amazing. You can throw together data APIs, few lines. There's so many ways to do it. As you saw, Heroku is very easy. AWS, DigitalOcean, they're all easy. And you can amortize these skills. That's what's nice. You learn to do them once, and that's that. The idea, I think that I push in the book a lot, and I think it's quite fundamental, is you can really limit the amount of web dev, or what you probably used to associate with web dev. You can really reduce that to a bare minimum, just creating a kind of a skeleton that you'll then flesh out programmatically, and then just turn all your energies to creating interesting, engaging, interactive visualizations with any luck. And that's it.
Time for a couple of questions. Remember to repeat them.
Yeah.
Great talk. Really loved it. Thanks a lot. So you're talking a lot about sort of visualizing data. I'm thinking the last major app I built, it was sort of more had a back end in Scala and sort of more Java based, and then with JavaScript at the front end. Are you sort of suggesting that you can almost completely do away with that also for larger scale projects, or how are you sort of thinking about more web application as opposed to visualization in terms of the stack?
In terms of the stack, sorry, yes. So the question is, I think if I understand you rightly, the degree to which I guess JavaScript is going to colonize the full stack. Or
yeah, and I guess also Python at the back end. I mean, because as you say, the libraries are so powerful for the data analysis. So the data is there. Do you need to put in Scala or another compiled language to serve the actual application?
Yeah, I mean, I guess I see it as a process of refinement. So you get your raw data, wherever it comes from. You might declean that. You refine it, and up to a point where, I mean, I guess you want the most refined data possible to be delivered to the browser, because JavaScript is not very good at doing very much. I mean, it's awkward to use JavaScript to do anything with it at that point. So I see it, I mean, I do see it as the Python or the Scala or anything else. Their job is to essentially distill the data, is to deliver a concentrated data form in a way that is easy to use. And generally, the rule of thumb is, you want your delivered data to be as close as possible to the stuff you'll be sending to D3, whatever, lowest number of manipulations. So, but you certainly do need other languages in the back end. JavaScript's data processing is not there, probably will never be, I think.
How high is the barrier to entry? Do you have to invest a certain amount of time before you start getting some payback, or can you get something up and running pretty quick?
Question is, how high is the barrier to entry? I think the barrier to entry is an awful lot lower than most people appreciate, as long as you don't listen to any JavaScript fanboys. Because they'll tell you need gulp and grunt and watch files and all the rest of it, and you don't. You just need an editor. There is I think there's some, obviously looking at the history of JavaScript, there is insecurity there, because a lot of people are used to being told they're playing with a toy language, and I think they've tried to fill that gap with lots and lots of tools and pipelines and pipe flows and all this stuff, and they've created this complex mess. It has its place probably if you're working with big teams, but I would say the barrier to entry is incredibly low. In fact, it's the lowest barrier to entry of any language I know, because you can go to JS Fiddle or JS Bin, play around. You can go to Block Builder for D3. There's 11,000 examples that are all active there. Active.
Literally just switch out your data for theirs.
There's 11,000 examples there. They have the code, they have the data. You can change the code, change the data interactively. That's why I think JavaScript was just elected the teaching language of the American Teachers Association. I think it's just overtaken Python. So yeah, it's low, I would say, as long as you ignore certain people. So, yeah.
Last question.
So you are just talking about, and in the previous slide saying about Go vanilla, don't use any of the tooling. Thing that I found is, at the beginning you also was mentioning about the newer versions of JavaScript that are much nicer and much more usable. And the thing is that most of them are not really well supported, so you start needing some conversion tools. How do you handle those differences? The thing of support with ES6 or newer versions.
Yeah, it's the question is, all these funky new JavaScript additions aren't quite there yet. They're very close. I mean, it's happening within the I would say 6 months or a year, if not less than that. And a lot of them can already be used. People use various things. I mean, there's kind of like Fable, I think, is one. And I personally, because I haven't been using them much, because I've got my old ways of doing it, so I haven't had to run into that problem too much. But I know Tom, who's sitting next to you. What would you use, Tom?
What for doing?
For compiling
So
ES6.
yeah, Fable nowadays.
Fable, yeah,
we
would
do
be
have
better.
an extra compile step, but
And you find that
there's
pretty...
some nice tools that kind of just run a server and it serves it up. You most of the time don't need to worry about it.
I get the impression, talking to people in the JavaScript community, that it works very well, and there are some debugging issues, but generally speaking, people are getting used to just converting their EcmaScript 6 into browser compliant code without much trouble.